In this discussion, we're introducing assembly theory, which is a new framework for understanding complexity, life, and even reality itself. The central idea here revolves around something called the assembly index. This index quantifies the minimum number of steps required to build an object from its fundamental components. And, this isn't just about physical construction. It also reflects the causal history and information that's embedded within an object. So I use the Lego analogy to kind of illustrate this idea. While the universe can theoretically create, an unimaginable number of configurations, what we call combinatorial space, only a tiny fraction of those actually exist. That's because creating complex structures like a Lego castle really requires a specific, hard sequence of assembly steps. Spontaneous formation is just, highly improbable for that level of complexity. This concept actually extends to molecules like Taxol, which is an anti-cancer drug. Even though Taxol has a relatively simple molecular formula, the sheer number of possible three-dimensional arrangements for that formula is vast, far exceeding the resources of our universe to produce them all randomly. This really highlights that existence is constrained by evolution and selection, which compress this vast possibility space into the objects we actually observe. Assembly theory isn't just a theoretical construct, it's actually measurable. Scientists are developing techniques like mass spectrometry, NMR, and infrared spectroscopy to determine the assembly index of molecules. Early experiments have shown a pretty distinct complexity threshold. Molecules above a certain assembly index, say 15, are almost exclusively products of life, which distinguishes them from abiotic or non-living samples. This suggests that only life can generate highly complex objects, because it involves selective mechanisms and information processing that scaffold complexity over time. So this actually leads us to a redefined concept of the origin of life. It's not merely a single event, but rather an ongoing process, where a system becomes complex enough to build a history and memory, recursively processing information to construct into the future. And, this really applies not only to biological life, but also to things like languages and technologies, since they too involve generating novelty out of combinatorial spaces. The discussion then delves into assembly space as a new kind of physical space. Just as coordinate space measures physical geometry, assembly space measures causal depth. This means that objects are not just extended in spatial dimensions, but also in time or causal history. Our own brains, for example, represent billions of years of constructed complexity within a small volume, suggesting that reality might appear increasingly virtual as our world becomes more complex, because our senses primarily interact with space, not deep time. The technosphere, the sum of human technologies, is presented as the largest known causal structure in the universe. While spatially small, its causal time volume is immense due to the accumulated historical contingency embedded within it. This leads to the idea that the universe doesn't predict the future, but constructs it, as the sheer volume of possibilities means the future is undetermined until it happens. Finally, the concept of first contact in the lab is introduced. Instead of waiting to discover alien life on other planets, the speaker proposes that we might first discover new forms of life here on Earth by building experiments that search chemical space for novel lineages. This would help us understand the fundamental physics of the origin of life transition and how the universe builds information processing systems. This approach also touches on the nature of AI, suggesting that while current AI might be shallow in assembly space, the integrated structure of our technologies is growing deeper. The true measure of AI's life or mind may lie in its ability to exhibit deep causal structure, which is a key question for future research within assembly theory.